but we'll see how it goes.
No bonus.
Maybe no bonus. I don't know. I am kind of tired. Okay, so here's what we got. Today we're going to talk about linear inverses and how to prove. Don't freak out when I say prove, because I know people have PTSD from geometry, right? I know, it happens every year. We're not doing formal proofs or anything, but we're just going to use a property of compositions to show if something is an inverse or not. So, like, don't stress about the word proof. But here's what's kind of on tap. We do have your a check for understanding next class. Remember, that's not going to be a weighted grade anymore. That's just kind of a check to see how you're doing. It'll be after a long weekend. I know, I'll give you some time to look over. It's going to have function compositions, which is what we did last time, and then inverses. I think it's like 3 questions. It's fairly short. Then we'll get into attributes of functions. So I may try to do a little pre-teach on that. Maybe not. I don't know. We'll just have to see how the lesson goes. But yeah, so that all is coming here. Remember, this is the 15th here is, I'm pretty sure, an eligibility check. This is just like for everybody and anything. And I also think the drop deadline is probably going to be around there as well. So just kind of keep that in mind as we're getting closer and closer to that, because we're just cruising along here. So let's talk about linear inverses. Chromebooks down. Chromebooks down. Everyone with the Chromebook open, put it away. All right, inverses. So again, some vocab here that we're going to talk through. We will touch on inverses later, maybe at the very end of the semester. It might not be till second semester. It just depends on how we do. But inverses are something that are not going away. They're going to come back again. They're not really that hard to do, but sometimes at the beginning, just to kind of talk you through what it actually means, we just have to go a little bit more in depth with some definitions here. But basically, an inverse function, inverse is opposite, okay? So you are reversing the pairings and operations of a function. So if you have an original function and you want to find its inverse, one way you can do it, you just swap all the x's and y's. Like if you have a table and you've got x's and y's, flip every x and y, and that'll give you points on the inverse graph. Same thing with an equation. We're going to be doing opposite operations of the original are happening to the inverse function. The inverse of a function may or may not be a function. That's going to be a really big deal when we see this the second time, okay? But just depending on what's going on, it may or may not. So what does it mean? We did this last time. What does it mean to be a function originally? What can't happen? Which is regular functions. You can't have 2 x's. Okay, x's can't repeat. You can't have an x going to 2 different y's. Y's can be repeated, and that's okay. However, when you do the inverse and you're switching those x's and y's, if you have repeating y's, the inverse is going to have repeating x's. So there are possibilities, and again, it's more going to come up when we see this the second time, whether or not the inverse is a function. There's a test for it, and we're going to talk about that after I do this first example. If the inverse function is not a function, then we just call it a relation, because we have to be like specific. And when we use the word function, that's kind of important there. And then notation-wise, if the inverse of a function f of x is also a function, we denote the inverse by f inverse x. I circled that right there. We kind of use the inverse thing with matrices. So you've seen that little -1 exponent looking thing. The only time this tells you you're talking about an inverse function, you also can denote an inverse relation as y inverse. Okay, that -1 tells you that it's an inverse. This means your inverse is a function. This does not mean that your inverse is a function. It could or it may not. So if you're going to use this notation, you just got to be careful. We're safe to use this notation right now, okay? And we'll make it safe for the rest of Algebra 2. I'm going to come back to this in a minute. But first, let's just look at our first example. We're going to be talking about inverses of linear functions today. We're just going to start there. We will build on this. Again, the second time we see it, we'll do other types of functions and their inverses. But for our intro, we're just going to do linear. So it says, find the inverse function of f of x equals 2/3 x plus 4. Write your answer in slope-intercept form. So this is slope-intercept form right now. Algebra 1 days, what's the slope? 2/3. What is the y-intercept? 4. If you were to graph that, let's go right here and graph this. I'm going to go up to my y-intercept, which is at 4. My slope is 2 over 3, so I'm going to rise 2, run 3. Weren't these the good old days when this is what you did?
Does that say 6 equals 4? B.
Where? Oh, no, it says B. B equals 4. Sorry, M and B. It's just really sloppy. Down 2, left 3. I think I have a ruler so I can make a pretty graph. Maybe I don't. I'm trying to make my graphs look pretty. We'll see here. And so here is my original function. Did not work out so well. That's okay. F of x. Okay. Just get that on there. Now I'm going to show you how we can go and find the inverse of that. Okay. I'm going to kind of do this in 2 different ways, and we'll see like what we like, or we might blend my 2 different ways of thinking about it. But what is happening, back to the original guy, f of x equals 2/3 x plus 4. What is happening to your inputs, to your x's? What are they doing in this function? What does this function tell you is happening? X's are being multiplied by 2/3 and then added 4. You're just following PEMDAS. So if it says original, let's write what we're doing. We're multiplying. We're following PEMDAS. There's no parentheses, no exponents. So we're going to do our multiplication first. Multiply by 2/3. And then we're adding 4. Okay? Inverse functions are all about opposite. Meaning my inverse functions is going to have the opposite of these things in the opposite order. So what is the opposite of, I got to work backwards, adding 4? Subtracting 4. So that's going to be the first thing that I do when I find the inverse. I'm going to subtract 4. What is the opposite of multiplying by 2/3? Dividing by 2/3. And this is the order that I'm going to write the inverse in. So PEMDAS when you have the original, SADMAP when you do the inverse. Okay, you just do the complete opposite there. So how I would write that for my inverse, let's do f inverse x. I'm going to write it kind of an ugly way, and then we're going to clean it up. Okay, I need my inverse to x's will subtract 4, so x minus 4. And then that whole thing is going to be divided by 2 over 3. Do you see why I said this is the ugly way? Do we like to have divide by fractions on there? We do not. This is not slope-intercept form. This is not how you're going to write your answers. Okay? What is dividing by 2/3 the same thing as doing? Multiply by 3 over 2. This is honestly how I want you to write it. So that way we can distribute it in and get it in slope-intercept form. We don't divide by fractions in here. It's really just keep, change, flip is all you're doing. But dividing by 2/3 is the same thing as multiplying by the reciprocal 3 over 2. So really, we should write this as 3 over 2 times x minus 4. The x minus 4 being in parentheses is real important. Okay? Really important because both of those things are going to be multiplied by 3 over 2. Now, is this in slope-intercept form right here? No. Slope-intercept form has no parentheses. So to get our answer in slope-intercept form, what do we have to do? Distribute. So let's practice multiplying with fractions because that's everyone's favorite thing to do is fraction operations. 3/2 times x is 3/2 x. 3/2 times -4. Remember, this is 4 over 1. -6. And this is my inverse function in slope-intercept form. Okay? So that's kind of one way that you can think about it is write out the steps that's happening to your inputs originally, reverse them, reverse the order, and write it out that way. I've honestly never taught it that way before, so that was kind of new. What I usually do is show a more algebraic approach. And what I would do for that, and I'm going to draw kind of a box here. So I'm going to do the same problem, and I'm going to let you guys kind of decide which one you like. I normally don't like to show you a bunch of different ways because it gets too confusing, but I feel like doing 2 ways is not that bad. Whenever you find an inverse function, I keep saying you're doing reversing. You're switching x and y's. You're switching the domain and range. So I can basically start with my original equation, which was y equals 2/3 x plus 4. And if I want to do this algebraically, I can just switch the x and y in the original equation. So I'd have x equals 2/3 y plus 4 like that. And then my goal is just to get y by itself. So how do I algebraically get y by itself here? What do I have to move?
The x and the y.
What do I have to move? Well, I already moved the x. What do I have to move? Subtract the 4. X minus 4 equals 2/3 y. Multiply both sides by 3/2. So you see how we're getting to the same thing? Do y'all see how we're getting to the same thing?
Yes.
It just depends on what way you like to think about it. And then I would need to distribute that through to get it in slope-intercept form. But either way is going to get you to the same place. Okay, so I should the same problem 2 ways. I don't know. I kind of like writing out the steps and then maybe going and showing it algebraically. So that way, if whichever way you're thinking about it, it can work. But here's what people do wrong on this. Not so many problems with linear, because linear are going to be the same 2 things. Subtract or add, multiply by the reciprocal. Those are kind of your steps. It's going to get crazier when we get into more advanced functions like later in the year. But knowing how to like isolate variables, move stuff over inverse wise is going to be really important there. So let's graph this line right here. F inverse x. What is the y-intercept of the inverse? -6. I'm going to go 1, 2, 3, 4, 5, -6. What is the slope of my inverse? So up 3/2 over 2. And I'm going to see if I can draw this line good. I really wanted these lines to be straight. Did I go? I didn't go over 2. Why aren't these? I didn't get these. Did y'all's cross?
No.
Dang it. They were supposed to cross. Oh well. They will at some point, but I wanted them to cross like a better... Oh, maybe I graphed the wrong one. Oh, shoot. I was supposed to graph this one on there. My bad. It's fine. We're not going to spend a whole lot of time graphing. Dang it. Okay, I'll show you the other one in the calculator. My bad. I was just looking ahead. So do y'all see on this grid, I'll call this F inverse of X. You can still see it. It's just not as like pretty as if you could actually see their intersection. Yes, they will cross eventually. Do y'all see the dashed line that's kind of already in there? Okay, that's the line y equals x. This is inverse properties for you, okay? When you have 2 inverses that are graphed, they're a direct reflection over the line y equals x. So each of these points, if I were to reflect it over the line y equals x, I would end up on my inverse graph. And I graphed the wrong one, so you can't see it as much. Here's what I was supposed to do. We were supposed to graph this one. So you can see, like, you see how this one's just better looking? It's because it's problem number 2, but that's okay. I'm not going to ask y'all to graph a whole lot here, but I just want you to see the connection of how these lines are just direct reflections of each other, and that's just a property of inverses in general. So my bad on that. Okay, let's go back to what it means to be one-to-one, okay? Again, bigger, more important when we do this later, but... what it means to be a one-to-one function. So we have our umbrella of functions. And what do we know about functions? Their x values cannot repeat. They have to pass the, what's this? Vertical line test. To be a function, you have to pass the vertical line test. To be a one-to-one function, those are kind of a subset under our big umbrella of functions here. And one-to-one functions obviously are functions, so their x's don't repeat, but more specifically, their y's do not repeat as well. So why do we care about that? Why do we need to know that? If a function is one-to-one, then the original and the inverse will be functions. That's why we want to know that, because we can test our original guy. If he's one-to-one, that's going to give us some insight that our inverse should also be a function. Our inverse graph will cross the vertical line test. Now, there is and someone asked this yesterday, is there such thing as a horizontal line test? And there is. Okay, and what the horizontal line test does is the same process. except for you're drawing lines this way. The horizontal line test will tell you if a function is 1-to-1. So if you look at your original, guys, so let's go to my wrong graph here for green. If I look at this graph passes the vertical line test, right? It's a line. All linear functions are going to pass the vertical line test. Okay, but also I can go through and I can draw horizontal lines, and this graph passes the horizontal line test, doesn't it? Okay, so that tells me my original line is 1-to-1. That tells me my inverse is going to be a function, and that's what I want to know for now. Okay, so that's like the scope of where we're going to take it. Lines are all going to be 1-to-1. This will be a bigger deal later. So is f of x 1-to-1? We're going to say yes. And we're going to say because the original, I should write in green because I'm talking about the original, passes the HLT. Just for fun, so you can see a function that's not 1-to-1. Okay, I'm going to move my paper for a second. This guy. Get ready because this guy is going to be a big part of your life in October. What function is that? It's a parabola. It's a quadratic. It's a function, right? Because it passes the vertical. But is it 1-to-1? No, because it does not pass the horizontal line test. So is this guy's inverse going to be a function? No. Okay, so that's why in December, January, whenever we do this, we're going to have to fix this guy to make sure that it is. So that's just like, again, some background knowledge. We'll come back to that later. But we're really just focusing on lines. Lines are always going to be functions. They're always going to be 1-to-1 because all I do is increase or decrease. Nothing crazy going on. So our inverses are going to be functions every single time. Okay? All right, let's try another one, just finding the linear inverse. F of x equals 2x minus 5. Write the inverse. Again, we're not going to graph because we already used our graph space because I am silly. And write your answer in slope-intercept form. All right, I'm going to do my original steps. What's happening to my original function? From this equation, 2x minus 5. In words, what's going on? Multiply by 2, subtract 5. So what's our steps for our inverse? Oh my gosh, I can't spell, I can't read, I'm struggling. Add 5 and divide by 2, which, what is dividing by 2 the same thing as? Multiply by 1/2. Okay? So my original equation, remember f of x is the same thing as y. I'm going to do this algebraically for you. I know these are my steps over here. This is the order I need to do everything, but I'm going to write it out. I'm going to switch x and y. So x is equal to 2y minus 5. Okay? My steps tell me what to move first. I need to add 5. X plus 5 is equal to 2y. I need to then get rid of the 2. And I want it in slope-intercept form, so I don't want to divide. I'm going to write this as a multiplication of 1/2. I'm wrapping x plus 5 in parentheses, and this is important that you make sure that you do that, because that's not slope-intercept form. How do you get it in a slope-intercept form? Distribute. I'm going to bring the y inverse in the front. Y inverse is equal to 1/2 times x is 1/2 times 5 is 2.5. I like fractions better, so I'm going to put 5 over 2. I wouldn't count it wrong if you did 2.5. Yeah.
Can we do 2.5 if we're graphing it? Because wouldn't it be easier to graph a decimal?
Yeah. But again, I don't believe I'm going to be really asking you to graph, but yes, I would do 2.55 as graphing. Yes.
Like numbers like 5.5 or like 5.75 is fine, but like if it's like 5.8.
Yeah. I don't, and I prefer fractions. I wouldn't count off if you put a decimal. I don't love though, like when 3 is the denominator or 6 and you get like repeating stuff. I'd rather a fraction with that. But if you were graphing, then yeah, you could use those there. Okay. Is our original 2x minus 5, is it 1-to-1? What did I tell you about lines? Lines are always going to be 1-to-1, right? I'll show you this graph again. 2x minus 5. Man, I just really botched that. Sorry, y'all. Y'all forgive me? It's okay. We don't forgive me? Okay, well. I'm sure you'll find a way to get over it at some point. Don't let it ruin your 4-day weekend that I graphed the wrong problem, please.
Gonna ruin it.
I really don't want that to happen.
Why do we have Friday off?
Forgot how satisfying it is.
Why do we have Friday off? I don't know. I mean, I don't have Friday off. I get to teacher work day, yeah. Don't be afraid of the fractions. Okay, so go to number 3. This is just asking you to find the inverse. That's going to be on the check for understanding. That's going to be what your Delta Math is today, is just finding inverses. It should be quick, okay? Don't freak out with the fractions. Just take them like one at a time. And we're going to find the inverse, and then we're going to talk about compositions and how these relate to inverses. I add in that inverse sign as soon as I have y by itself. So like in this set, multiplying by 4/5 is how I got y by itself, so I added in the inverse sign right there. Okay, fractions, people. Fractions are our friends, okay? They're not scary. What is 4/5 times x? 4/5 x, okay? And then 4/5 times 7/2. You can just keep doing your normal number operations. You're multiplying 4 times 7, which is 28. And then 5 times 2, which is 10. And then that simplifies to 14/5. But I also want to show you, you can sometimes, here's your answer. Delta Math today is going to have you, and your test, I believe, is going to have you put it in slope-intercept form. And Delta Math is going to want the fraction forms, especially if it's repeating decimals. I wouldn't do that there. So you can always go back to multiplying across, and then simplifying. But also, for fun, in case you don't remember, if you're doing this operation right here, you can also simplify before you start multiplying. Meaning, I can simplify a numerator with a denominator. So, like, what do you know about 4 and 2? What do you know about those? They're both divisible by 2. 2 goes into 2 how many times?
2.
No. 1 time. 2 goes into 4 how many times? 2 times. So I can kind of cross-simplify there. And then I'm just doing, okay, I can't simplify 2 and a 5 or 7 and a 5. But now I'm just doing 2 times 7, 14, 5 times 1, 5. It's a little bit faster, because what if you have a fraction like, I don't know, 35 24ths times 82 something that goes into, I don't know. But if you don't want to do all that crazy big math, you can try to simplify across within. And again, it's just reducing. You're just reducing pairs that you can. Okay? And then that will give you your...
So that's what you put in Delta Math?
You would put the box. Yeah.
Is that what you put elementary school people?
Focus in. New part for today. We're not doing proofs. But we're showing our work using composition. So here is a property. Remember, we did compositions last time, so it's kind of a refresher on what we did last time. But if you take two functions, call them f and g, which are inverses of each other, if they truly are inverses, then if you compose them, put one as the input into the other, they will simplify down to be x. And you have to check the other way. Okay? So here's the property. I'm going to highlight it. And so my question and how you're going to see this is like this. Verify if these two functions are inverses. Okay? Here's what you should not do if you want to get full credit. If it says using compositions of functions, you better be doing compositions of functions. Don't just find the inverse and be like, nope, it doesn't match. Okay, that's great. That's not what I'm asking you to do. I want you to prove it to me using compositions. You will see this question. You will have to have your algebra back it up. And you do have to check by composing them with each other. So here's our two functions. F of x equals 3x plus 4. G of x equals 1/3 x minus 4/3. The first way we're going to check, it doesn't really matter which one you do first, but we're going to compose f of g of x. And we want to test and see, I'm going to put a question mark, is that equal to x? If it is, I got to check the other way And if that is also x, then yes, these guys are inverses because this is true and this is true. If you do one composition and it doesn't give you x, you can stop there. But if you get a yes, you have to check the other side. Okay? With compositions, where do we always start? Inside. Inside. So in this case, we're taking g of x, 1/3 x minus 4/3. This is my new input. And I got to put this function as the input into what? The outside. Okay? So f of 1/3 x minus 4/3 is equal to, and make sure you look at the right function. F of x says 3 times your input. So 3 parentheses, my input, which is g of x, 1/3 x minus 4/3 plus 4. Okay? Plus 4. So this is what we did last time. I know it looks a little crazy. We're just going to clean it up. I'm trying to make sure they're equal to x. 3 times 1/3 x. Again, check the cross thing. 3 over 1 times 1 over 3. What happens to your 3's? Simplify to be 1. Cancel, but we say simplify. So this becomes 1x. 3 times negative 4/3. 3 over 1 times negative 4 over 3 times negative. What happens with the 3's across? They simplify to 1, and you're left with negative 4. Drop down to plus 4. What's x minus 4 plus 4 simplify to be? Okay? So, we're halfway there from showing that these are inverses. Why are we halfway there? Because f of g of x equals x, right? This is the goal. You get anything that is not x, it's not going to work. But we got to try the other way around. Okay? So this is a check. Now we got to try the other side. G of f of x. Is that equal to x? That is the question. Start in the middle. F of x is 3x plus 4. That's the input. Put this in to function g. Function g says 1/3 3x plus 4 minus 4/3. There's your plugging in the function into the other. Now we clean it up. 1/3 times 3x. That is x. 1/3 times positive 4. Positive 4 over 3. Minus 4 over 3. What is this equal to? X. So what do we know? They are inverses. Here's what I want to see on your paper when you see a question like this. Yes. F of x and g of x are inverses. Exclamation point, because we're excited. Why? Why are they inverses? Because, what did we prove? F of g of x equals x, and what else? Very good. That is your explanation. I don't need a paragraph. This will do. Yes.
So we can say that they both equal x.
I want you to at least write down the compositions. The compositions both equal x. Okay, common misconception. Let's see if this happens on one of these. I think it's going to happen on one. Y'all do number 5 real quick. Do number 5, and then I think I want to do 6 together. and then we'll delta math. All right, so you had to compose the two. That's the name of the game. If you're proving by compositions, you got to do, and I will say, delta math practice is literally just find the inverse, find the inverse, find the inverse. So I am going to have you guys do 6 and 7 because there's not delta math on this. This will be on the test. This will be on the check for understandings. You have to know how to do that, but they just don't have delta math practice for it. But when you are using compositions, again, it's in the instructions, and I'm telling you, and you're all listening and looking at me right now. If you don't use compositions, you're not going to get full credit on this question. Do you understand?
Yes.
And y'all will whine. I'm going to be like, you have to read, okay? So this is what I'm checking. When I plugged in h of x, which h of x was kind of crazy looking. It was a fraction. But guess what happened to the 4's on the outside?
They canceled out.
They simplified to 1. Simplified to 1, and I was left with x minus 2 plus 2. Minus 2 plus 2 is 0. I got x. If you get x, you have to check the other side, okay? But you probably should work out if the first side works out. On this side, up in my numerator, I put parentheses around the 4x plus 2. Did I really have to do that, though? No, because there was nothing in front of this x right here. But I just put them in there because that's just typically what I do whenever I put a new input in. However, I was able to simplify the plus 2 minus 2 to 0. That lets me with 4x over 4. 4 divided by 4. 4x divided by 4 is x. There's my answer. Yes, they're inverses. Why? Because the compositions equal x. It's a mouthful to say. It's not that hard to write. Okay? Let's look at 6 real quick. Is G the inverse of J? What's the first thing y'all want to check? Which one do you want to do first? G of J of X. Thank you. Again. Thank you. All right. Is it equal to X? That's the question. Did y'all also see how I kind of skipped a little step and I just went G of, and I went ahead and put J in here? Are y'all okay with that? I'll just put it right there. Okay? All right, so let's write this out. Oh, I don't have enough room. 2 times negative 2x minus 3 plus 3. Be careful on these when you have like a bunch of functions floating around that you're using the right one. Okay? When I distribute that through, this is going to become negative 4x minus 6 plus 3. What does that simplify to be? Is that what I need? No. So what do I know right now?
They're not inverses.
They're not inverses. If you get one no, you don't need to go check the other side. Okay? So you can, but
Well, you count up points if we don't.
not with a no. I'll count off points if you don't with a yes. If the answer is yes, and like I made the answer key, I know it is, I gotta see both. If the answer is no, I'm gonna check for one. If you want to do both, that's fine. But there was like, I don't know where it happened. But I feel like there was one time we had a problem. Well, I don't know, I might say too much. But anyways, if it's not equal to x, then you just need to tell me that no, they are not. And the reason why, and here's how you can write it. You showed me G of J of X, it did not equal X. That's enough. That's enough for me to know it's not going to work. Okay? And so that would be your answer there. All right, try number 7. And then your delta math for today is just linear inverses. It is just 5 problems. So you're going to get it all done today. Okay?